Welcome to Ajat Bioacademy. Today's lecture topic is troponin, their position, their location, their function. But today's main topic is types of troponin, their role. So firstly, I will say here is the actin filament. This is the double helical structure. So you can say in that way. Okay. So you can say here like that. This is actin. Okay. And actin is not free like that. Each 7 monomer of the actin, that means you can say one bead, another bead, another bead. So 7 bead interval, monomer of actin interval, special types of protein complex is present. So that protein complex, you can say this is one, this one is another, this one is another one, that is like that, and you can say this one is another, that is this. Okay, so this is called troponin complex, and here you can say this is troponin C. You can say this is troponin I, and here you can say this one is troponin T. Okay, already I said in 7 monomer interval the complex is there, so here also like that. Okay, and you can say over there also. So in that way, actin filament can carry multiple troponin complex. Okay, multiple troponin complex. This is not enough because actin is free. Till now actin is free, but in normal state actin will not be free. So what will happen? Each chain, all the beads are just protected by a layer like that, and also like that. Okay, that means each bead of the actin is not free. This is, you can say this is a binding site, this is binding site. That binding site is blocked by chain. This chain is called tropomyosin. Okay, so this is tropomyosin. That means actin filament is blocked by the tropomyosin, and it is completely positioned properly by the help of troponin complex. And here are 3 types of troponin. I will just shortly say the function of troponin is to bind with the calcium, and that conformational change will help to displace the other troponin, and it will finally displace the tropomyosin. And troponin I, in the absence of calcium, it will help to inhibit the myosin binding to the actin. And troponin T, it will maintain the overall position of the tropomyosin and troponin complex. Okay, this is the normal condition. From the sarcoplasmic reticulum, the storekeeper of calcium, that calcium will come out and it will increase intracellular calcium. Okay, and that calcium will bind with the troponin C, and it will change the conformation, and it will inhibit the function of, change the function of troponin I, and also it will give the message of troponin T to just translocate the tropomyosin from the actin. Okay, so what will happen? So this tropomyosin will be just change its position. The binding site of the actin will be open because the tropomyosin already displaced from that part with the help of calcium binding with the troponin C. Okay, another thing that can be helpful, like from the ligand binding, you can say noradrenaline, beta 1 receptor activation by signaling pathway, PKA, that is protein kinase A production will increase, and that can contribute. How? That protein kinase A can phosphorylate the troponin I. When troponin I will be phosphorylated, the inhibitory function of troponin I will be removed. Then what will happen? It will facilitate more calcium binding to the tropomyosin C, and it will help the troponin T to just translocate the position of the tropomyosin, and also it will maintain the overall position of the troponin complex. When actin will be free, then myosin head will attach with the actin with the help of ADP and inorganic phosphate. That means hydrolysis of ATP